Now we're really getting to the good stuff here. We're learning how to use the factor theorem to factorize, but now we're not being told what the factor is that we should be factorizing with first. All we're told is literally just the expression and told to factorize that. We will still be using the factor theorem, but we need to know what the actual factor is. And so if the factor isn't given to you, unfortunately, you're going to have to guess and check using the factor theorem until you find the first factor. This sounds like quite a lot of work. Guessing and checking has always been one of my least favorite things to do because it seems like kind of luck whether you get there or not. But I've got a strategy down here for you that should hopefully make it a little bit easier. So for a monic polynomial, remember monic, this is an example of a monic polynomial. The leading term is just the x, it has a coefficient of 1 in front of it. So for a monic polynomial, what you can do is that the linear factors will be in the form x minus b, where b is a factor of the constant term. This is the constant term, right? This is the constant. Our factor has to, the number in the factor has to go into the constant. It has to be a factor of the constant. The reason for that is if you have all of your brackets and then they'll have some like maybe x plus blah, x minus blah, x something else. There'll be numbers here. And when you do FOIL, when you like expand everything out, you will notice that at one point all the constants get multiplied together, and that's what forms the constant at the very end. That's the only number that doesn't have an x in it, so all the constants from all the brackets actually get multiplied together. So if you're trying to find a bracket, it makes sense that the number at the end of the bracket has to be a factor of the constant, because in the end when you expand it, it makes out to be the constant. It's part of the constant that you can create. Hopefully that's a bit of intuition, and that's what we're going to use as our guide to figuring out what to guess. So we're not guessing randomly, we're guessing with a bit of a strategy. So what you're going to do is you're going to write out the factors of the constant, and then you're going to check them with the factor theorem from smallest to largest. The reason I say from smallest to largest is because the factor theorem involves you substituting in values and evaluating them. If you're going to be doing lots of guessing and checking, you should be starting from the smallest because they'll be the quickest to do, so you'll be minimizing the amount of time it takes you to find your first factor. Once you've found the first factor, you can continue from there with your long division and you're doing good. Also, don't forget to check both positive and negative, because no matter what the sign is of this one, you will have positive and negative possibilities for the factors of this constant. I think I'll just go into this example and hopefully this will make a bit of sense. I'm going to start by writing out the factors of the constant term. The factors of negative 12 are, starting with the smallest, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. We probably don't want to get up to the 12, especially if we're doing this by hand. It could be a lot of work to do all these substitutions. We're going to start and go in that direction. Now I'm going to write the corresponding divisor for us to be able to check it out. The corresponding divisor for this one would be x, would be the opposite sign, so it'd be minus plus, technically, 1. This would be x minus plus 2, x minus plus 3, x minus plus 4, and so on. So whichever one of these is the factor, that's the corresponding divisor that we're going to use for our long division. So let's get started. I also like to start with the positive signs first because it makes it a little bit less work. So our polynomial, let's just give it a name, p, is equal to x to the power of 3 minus 13x minus 12. And let's go starting with the smallest one, p of 1 equals 1 cubed minus 13 times 1 minus 12. That gives you 1 minus 13 minus 12. That's equal to minus 24. Now we've reached a number, we have to make a decision. So is +1 a factor or not? We figured out that the remainder is equal to -24. Since this isn't 0, then we can say that x minus 1 is not a factor. And the reason it's x minus 1 is because, remember, you equate this to x, and then you rearrange to get x by itself to get the divisor. So it's x minus 1 is the divisor. You rearrange to get the 0 on one side. I like to think of it, when it's a single number, I just like to think of it as swapping the sign. Okay, so that was not very fruitful. This is not a factor. This hasn't helped us because we can't continue without finding a factor. So we'll go on to the next one. We're now going to try p of -1. So -1 cubed minus 13 times -1 minus 12. -1 cubed is -1. Minus 13 times -1 is plus 13 minus 12. And then -1 plus 13 is positive 12. Minus 12 is 0. Awesome. So we have found 0. This is great. That tells us that x plus 1 is a factor. Okay, so as you can see, we didn't really even need all of these because we started from the smallest one. We have found the smallest number factor that goes in. There might be other ones. We might find some others there as well. But since we started from the smallest, the calculations were the easiest for sure. Okay, we have found that x plus 1 is a factor. I'm going to note that down up here and then make some space. So we know that x plus 1 is a factor. Bear with me for a moment. So now that we have a factor, we can start doing our long division, which will help us find the next part of our expression that we can factorize further. Remember, when you're doing long division, if there is a missing one, we have to add a 0 as a placeholder to keep that column in existence, basically. Right. Now, what is x multiplied by to give x cubed? It's just multiplied by x squared. Now, multiplying the x squared onto the x is x cubed. Multiplying the x squared onto the 1 is x squared. Subtracting that away, we have x cubed minus x cubed, that's just 0. And then 0x squared minus x squared is minus x squared. Bringing down the other numbers, and we can repeat. What is negative x squared multiplied by, what is x multiplied by to get to negative x squared? That's just minus x. Now subtracting, minus x times x is minus x squared. Minus x times 1 is minus x. Adding those together, subtracting those, but this will end up being adding, so minus 13x plus x is minus 12x minus 12 from there. And last time, what is x multiplied by to give negative 12x? That's minus 12. Multiplying minus 12 onto the divisor and writing it underneath, minus 12x minus 12. Subtracting, and now subtract top from bottom, it's the same thing, so we end up with 0. Again, this is one of those checkpoints where you can breathe a sigh of relief because it means that you've done your long division correctly since you've got a remainder of 0, so you've still got all the factors correct. Alright, now let's put our polynomial and write it out as the divisor multiplied by the quotient. It's x plus 1 multiplied by the quotient which we've just found, x squared minus x minus 12. And now, because the question is to fully factorize, let's see if we can continue to factorize our x squared minus x minus 12. And we can do that with the cross method. So if we start with this side has to just be x's. And then once again, we're coming back to our factors of 12. So the factors of 12 that multiply to give a negative, so one of them will be positive, one of them will be negative, and then they have to add to give a negative number. So the bigger number will be the negative number, and they have to have a difference of 1. So probably 4 and 3. Let's try to verify that. doing the multiplication along the diagonal, x times -4 is -4x, x times 3 is plus 3x, and that gives you -x, which is the middle term, which means that we found the factors correctly. So all we have to do is put this into one bracket and this into another bracket. We'll keep this bracket going, and then we'll put the first bracket x plus 3, and we'll put the second bracket x minus 4. And now that's a fully factorized expression for p of x. The good thing is you can see we have x plus 3 and we have x minus 4 here. So if you were doing what we did at the start with the factor theorem, you would have also found a factor if you did p of -3. That would have given you 0. And p of 4 also would have given you 0. But it probably would have been a bit more work because you have to do all this by hand. You have to do all this arithmetic. So we're lucky, since we started by the smallest one, we figured out x equals to +1 by doing p of -1 equals to 0. We figured that out first, and then we were able to find the harder factors by doing a trusted method which has a reliable answer, unlike the guess and check steps.